So in this lesson, we're going to be going over section 1.2 from the OpenStax textbook, and that is on integers. So the first thing that we're going to go through, and again, this entire chapter 1 is really a lot of review things from algebra and even pre-algebra, but this is a very important concept for algebra, and that is negative numbers. Right, and so there's a good chance you're already familiar with them. If you're already super comfortable with negative numbers and adding and subtracting, multiplying and dividing, feel free to skip this video, because that's pretty much what we're going to be going over as far as the integers go. But if you're, coming and being introduced to negative numbers for the first time, or you just feel like you need a review, then hopefully this video will be helpful for you. So the first thing we're going to go over is what are negative numbers, right? And so the basic idea, so I'm just gonna, write here, negative numbers, right? That's what we're dealing with today. And when we're working with negative numbers, I think it's always helpful to look at the number line, because that just kind of really displays where we see these numbers. So we've got, 0, right, is going to be right in the middle of the number line. 0 is like our starting point, And then if we go to the right, and hopefully you're kind of familiar with this already, we're going to have like 1, 2, 3, 4, and it would keep on going forever, right? And then negative numbers are what we're going to put on this left side. So we put a negative number, we signify that by placing a minus sign right in front of it. So minus 1, minus 2, minus 3, and minus 4. Or negative 4, 3, 2, 1. So you'll notice the first thing is that they actually count in exactly the same way, right? It's still 1, 2, 3, 4. We just have a negative sign or a minus sign in front of all of them. And they're going in the opposite direction, right? So the positive numbers are, and that's what these guys are. These are the positive numbers. These are the negative numbers, right? So I'll say plus, minus, right? Positive and negative. The positive numbers go to the right. So 1, 2, 3, 4. As you go farther to the right, the number gets bigger, right? Whereas the negative numbers, you go farther to the left and the number gets bigger. And so that idea is going to be kind of important, because it turns out that negative 4 is actually less than, say, negative 2. And that's because it's farther to the left on the number line. So we can't actually just look at the size of a number, like 4, 5, 6. We can't just look at that when we're figuring out if something is less than another thing. We actually also need to look, really what we're looking at is where is it on the number line? Is it more to the left? Then it's less. If it's more to the right, then it's greater than. And we will get more detailed with how that's going to play into addition and subtraction. So one thing I think is always helpful when we are working with negative numbers is to kind of illustrate this with a real world example. Because there's actually quite a few examples of negative numbers in real life, but the one I'm going to be talking about here is, let's say that you don't have any money, but you need to pay for something, right? And let's say that something costs $200, right? If you're needing to buy something for $200 and you have no money, what can you do? Well, you might take out a loan for $200. So what does that mean, right? Now, if you've taken out a loan for $200 to pay for something, and I ask you how much money do you have now, so let me actually move this thing down here so I can, loan for $200, you could say that this means you have negative $200, right? Because you don't have any money, but you actually have less money than not having any. You actually owe money, right? So you have negative $200. You went below 0. Another example would be, let's say, you're we've got like the beach here, and then we have the ocean water here, right? Sea level. If we go up this way, that'll tell us how high we are, right? Our height above sea level, right? If we go down, that's telling us how low or how far below sea level we are. And so what this means is, okay, let's say I'm up here. That could be maybe 20 feet above sea level, right? If I go down here, it's not 20 feet, it's 20 feet below. And so the way we might signify that below is we'd say it's negative 20 feet, right? So those are just some examples of how we could see negative numbers come up in real life. And it's a very similar thing. And it's really the thing that negative numbers give us is more than just a magnitude. It gives us a direction. And that'll be really interesting if you're doing any physics or anything like that. That's when you'll kind of see negative numbers are used a lot in real life to say like, oh, are we going forwards or backwards, right? That kind of thing. So I'm actually going to copy this number line here. So let's or just okay, copy. Oops. Paste. Okay. So this is our number line, and we're going to so when we look at this number line, and let's say we look at the number -4 here, right? So just highlight this right here. That's what we're looking at. And if you go to -4, a question you could ask is, how much do I have to add to get back to 0? Right, so if I'm at -4, what could I add to -4 to get back to 0 here? Well, you'd have to add +4, right? Because you're going to have to go a distance of 4 right here. That's a distance of 4 in the positive direction because you're going to the right. So in order to get from -4 to 0, you have to add 4. And so you'll notice that that's actually the same for all these numbers. If you take the negative and you add the positive, you're always going to get 0. And because of this, so actually let's build on some of the things we've learned from the last lesson, right? We learned about how we can use variables to write general statements about numbers. I could say, okay, -x plus +x is going to equal 0, right? That just means any negative number plus the corresponding positive number is going to equal 0. And because of this, we call negative numbers the opposites of the positive numbers, okay? So basically, you could think of this little negative symbol here. You could think of that as being a negative sign or a minus sign. You could also think of it as being an opposite sign, right? Because if you look at the number line, this 4 here is exactly opposite to where this 4 is. So the -4 is exactly opposite to the +4. And that's just part of the nature of how negative numbers work, is that whenever you add the negative to the positive, you're going to get 0 because they are exactly the same distance apart from 0, but they're in different directions, right? And so it's kind of like, okay, if you say 4, we start at 4, that's like taking 4 steps forward. And then you say, okay, let's add -4. Well, now we're taking 4 steps backwards. We're going to get back to 0. And so because of this, this idea that both the negative and positive numbers, they're in different directions, but they're the same distance away from 0. This distance away from 0 here, which I labeled 4 up here, let me just kind of highlight that again. that distance is what we call the absolute value. And this is the next idea that we're going to talk about. So we're going to call this the absolute value. And what this absolute value is, well, it's exactly what I was just saying. It's the distance of a number from 0. Now, the interesting thing about a distance is it's never going to be negative. It's not telling us which direction we're going away from 0. It's just telling us how far, right? It's not saying we're going to the left or we're going to the right. It's just saying this is how far, right? And so what this turns out to mean is that absolute value is always going to be positive. So, for example, we write absolute value using kind of these lines around a number. So the absolute value of 5, basically what we're asking is how far is 5 away from 0 on the number line, right? So if we say 0, okay, maybe there's 1, 2, 3, 4, 5. These are all negative. And this is 1, 2, 3, 4, 5 in this direction. How far is 5 away from 0? So what is this distance? Well, I mean, it's 5, right? It's always going to be that exact number there. So the absolute value of 5 is 5. Okay, what if we took negative 5? So what's the absolute value of negative 5? Well, how far away from 0 is negative 5? That's going this direction. So that's 5. Well, it's actually also going to be 5, right? Not negative 5, because we don't care about which direction we're going. It's just 5, a distance of 5. So that's also going to be 5. So both 5 and negative 5 have the same absolute value. And it turns out that, and as we've learned to write things generally with variables, the absolute value of any x is going to equal x, and the absolute value of any negative x is going to equal the positive x, right? That's basically what absolute value is going to mean. It's kind of like a function that says make it positive, right? Whatever it is, it's going to be positive. That's all. Otherwise, it'll stay the same. But if it's negative, we're going to make it positive. If it's positive, just don't do anything. So that's what absolute value is going to do. It's telling us, again, how far numbers are away from 0. And now that we kind of have this idea of how negative numbers work, right? This is like, a direction going left or downwards or whatever it is. I kind of often think of positive as going forwards and negative as going backwards. Now that we have that down, we can talk about how we're going to use negative numbers in our mathematics in real life, right? So let's say that, we have the counting numbers, right? These are the numbers that we're super familiar with, right? 1, 2, 3, 4, ... right? We all know these numbers. We learned them very early on. We count them on our fingers. We call them the counting numbers, or another name for these are the natural numbers, okay? So we have these, okay? And that's basically telling us everything that's to the right of 0 on the number line. You'll notice 0 is not included over here. 0 is not one of the natural numbers. So what if we wanted 0? Well, we could add 0 right here. 1, 0, 1, 2, 3, 4, ... Well, we actually have a name for that too. This is called, or these are called, I should say, the whole numbers. So we have the natural numbers are just, everything to the right of 0. The whole numbers are 0 and everything to the right of it. Then we have the negative numbers that we just learned about. So where do those fit into everything? Well, if we add the negative numbers to this set, which is, it's going to get pretty long here. So negative 4, negative 3, negative 2, negative 1, 0. Actually, I'm supposed to have a ... here, because that goes infinitely in that direction too. So ... Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, ... We call this, or these, the integers. So this set here is called the integers. And I'm sure you've heard this before. These are a very, very important set of numbers for math. And it's a lot of numbers, right? and it allows us to do a lot of things. Now, when we're adding and subtracting integers, we have to worry both about the positive numbers and also the negative numbers, right? So we're probably familiar with 2 plus 2, right? We're adding two positive numbers, and 2 plus 2 is going to equal 4, right? 2 plus 2 is 4. That's how we add positive numbers. Now, the question is, what if we added 2 plus negative 3, right? Well, what's that going to be? And to kind of work on that and how we will visualize that, if you're not familiar with that already, the OpenStax textbook actually has a really great illustration, and so I'm going to use it. What they did is they said, okay, we're going to have two colors, okay? And so we're going to have the positive color, which is going to be blue. So any blue circle things here, that represents a positive 1, and the red ones are going to be negative, okay? Just like this, right? So when you see a blue circle, it's positive. When you see a red circle, it's negative. And so let's just kind of add this number here. So if we have 2, right, positive 2, that's going to be these blue circles. So we have 2 of them. Okay, and then we're adding minus 3. Okay, so that's going to be negative 1, negative 2, negative 3. Okay, and so here's the interesting thing, and this is why I did them with the blue on top. When we take the when we take these pairs, when we get these pairs of positive and a negative, these pairs like this, those will cancel each other out, right? So those go away, and whatever we're left with right here, let me not do that in purple. Oops. Whatever we're left with over here at the end is what we get. So what's that? Well, that's a negative 1. So 2 plus negative 3 is going to equal negative 1. And that's a good way to visualize it, especially when you're just kind of starting out with it. So, okay, we've done that. Now let's say we add, and I'm taking this example from my notes. Let's say we add 5 plus negative 3, right? Well, if we use our circles here, we're going to get, I'm just going to, let's see, okay, 1, 2, 3, 4, and 5. Then we're going to have our minus 3, right? So minus 1, minus 2, minus 3. Okay. So now these cancel out, and we're left with the positive 2, right here. So that will be plus 2. Now you'll notice when we add a negative, this is actually the exact same thing as if we were just say 5 minus 3, right? 5 plus negative 3 is the same as 5 minus positive 3. And so this is going to be an important concept, so I'm going to write it out, I guess, in blue. Adding a negative is the same thing as subtracting positive, right? Adding a negative is the same as subtracting a positive. So what this means, and actually vice versa, right? So subtracting a positive is the same as adding a negative. And this is an interesting thing to look at because we have, oh my spaces are weird there. Okay. So let's take an example. Yeah, okay. So let's say we wanted to do 3 plus -5. So the interesting thing here is we could write this just as easily as 3 minus 5. Either one works. Sometimes it will be more helpful to write it one way than another way. And that just will depend on the situation. But in this case, it doesn't really matter that much. It's a really simple situation. If we do 3 plus -5, that's kind of looking at it like, 3 blue circles and then 5 -1s, right? These ones cancel and we're left with these two. If we look at it more like 3 minus 5, that's going to be kind of like saying, okay, we have 3, and then we take away 1, take away 2, take away 3, and then as we keep taking away, it's just going to start making red circles, so 4 or 5. It's a lot easier to visualize with the addition with these circles, but it's just important that you're able to recognize. If I say 3 plus -5, it's the same as 3 minus 5. It's also important to recognize if I say 2 minus 3, that's the same thing as 2 plus -3. And it'll kind of make more sense how this is helpful in later lessons and when we kind of start doing a little bit more complicated expressions. But that's just an important thing to remember, so I'm just going to, again, let's just highlight this up here. So adding a negative is the same as subtracting a positive. That does not look good when it's highlighted, but okay, so now, and I just want to repeat again my way of looking at it as taking steps forward and taking steps backward, because I think that, just saying it in a few different ways might help really get it down. So if I say 3 plus -5 again, right? That's like saying I'm taking 3 steps forward, and then I'm taking, so okay, 3 steps forward, and then I'm taking 5 steps backward, so 1, 2, 3, 4, and run out of room here, 5. How many steps did I end up taking? Well, I took those, overall, I ended up just taking 2 steps backwards. That's the overall result of what happened. And so it can get a little bit tricky when we're adding and subtracting positive numbers. I'm just going to continue kind of giving some examples. So this example is 7 minus, and we're putting in parentheses, -4 minus 3. This is from the textbook, minus 9. Okay, so we're gonna be talking about a few things here. So first of all, we're gonna be following the order of operations that we talked about last time, PEMDAS. So what happens first? Everything in parentheses, right? So if we say 7 minus, we have -4 minus 3, right? So what does that mean? We've taken 4 steps to the left of 0 on the number line, and now we're gonna take 3 more because subtracting a positive is the same as adding a negative, right? So we've gone 4 steps back, now we're going 3 more steps back. -4 minus 3. And so that's going to give us a -7, right? Because 4 plus 3 is 7, and it's negative. And actually I can now take I'll leave that parentheses there right now. And then -9 is still there. Okay, this is another important thing to look at. When you have 2 minus signs in a row, so when you're saying, in this case, 7 minus -7, that actually turns out to be the same thing as just 7 plus 7. So these 2 minus signs here end up just becoming a plus. And that happens in all kinds of places, and it's just an important thing to be able to recognize. If I say minus minus, that's just a plus. And you'll see a similar thing actually in multiplication as well, which we'll get to. So okay, if this minus minus is going to be a plus, then we can rewrite this as 7 plus 7 minus 9, right? 7 plus 7 is 14, and then 14 minus 9 is 5. So, it's just it's kind of getting used to this idea of we can actually go backwards even farther than 0, right? And I think the more and more you do this, it'll start to feel really natural to do. Just keep on doing exercises. There's exercises in the OpenStax textbook if you want to do those. And yeah, just keep on doing them. So now we've talked about addition and subtraction. We're going to talk about multiplication and division. So this is going to be very interesting as well. There's really, when you're multiplying and dividing positive and negative integers, right? There's only really 2 rules that you need to remember. The first rule, and I'm gonna just call this mult and div, right? Multiplication and division. Okay, so the 2 rules you need to remember. Rule number 1: if the numbers being multiplied or divided have the same sign, then the answer is positive. So same sign, the answer is positive. Different signs, right? Then the answer is going to be negative. Let me show you what I mean. And this is for we're multiplying and dividing. Wow, I said mut and division. Yikes, that's not what we meant. Multiplication and division. Okay. We're specifically talking about multiplying or dividing 2 numbers, okay? So, let's say we multiply 5 times 3. Well, that's going to be 15, right? And notice they have the same sign. They're both positive. Both of these numbers are positive. And it's going to equal 15. The answer is positive. So if both of these are positive, then the answer is also going to be positive. Now, let's say they were both negative, right? So we have negative 5 times negative 3. What's that going to be? Well, it's still going to be 15. Why? Because they have the same sign. These 2 negatives here cancel each other out, just like we did when we had 2 negatives that turned into a plus here. It's sort of similar. Both of these negatives cancel each other out, and so it becomes a positive, right? So these are both negative. This then becomes positive. And so you can see either way, whether it's positive or negative, as long as they have the same sign, the answer is always going to be positive. If they have different signs, so let's come over here and say negative 5 times 3. If they have different signs, the answer is going to be negative. Otherwise, everything's going to be the same. We're still doing 5 times 3, which is 15. But because they have different signs, it's going to be negative, right? Because we only have one negative. It doesn't get canceled out by anything, so it carries through. Same thing if we had, if we did 5, positive 5, times a negative 3, that would also be negative 15 again. Because they have different signs, so the answer is going to be negative. So just really remember these 2 rules right here. These are super important in multiplication and division. And this will become super natural the more you do it. Let's say you're going to multiply a bunch of numbers at the same time, right? Like, 3, 4, 1,000. And you wanting to figure out, is the answer going to be negative or positive, right? Because these are all different numbers. Some of them are positive, some are negative. What's the answer going to be? And so then these rules aren't going to matter as much, these 2. Instead, we're going to have a couple of other rules. So when we're multiplying and dividing a lot of numbers, more than 2, then if there's an odd number, so odd number of negatives, then the answer is going to be negative. If there's an even number of negatives, then the answer is going to be positive. And the reason why that is the case is because if there's an even number, then it can be split up into little pairs of negatives, and we saw right here how, when you have two negatives, they cancel each other out. So if you have an even number of negatives being multiplied, then they'll all cancel each other out, and you'll end up with a positive answer. If you have an odd number, all of them will cancel except for one, which will make it negative. I'm going to show some examples to demonstrate this. So let's say we have 2 times negative 3 times 4. So first let's just do the regular multiplication. 2 times 3 is 6. 6 times 4 is 24. And now we say, okay, do we have an odd or even number of negatives? Well, we have just this one negative here, right? 1 is an odd number, so the answer is going to be negative. Why? Nothing canceled out that negative number, right? He was just on his own. Okay, what if we did more? What if we did negative 2 times 5 times negative 3 times 7? Okay. Well, what we have here, 3 times 7 is 21, 2 times 5 is 10, 21 times 10, that's going to be 210. And then is the answer going to be, this is supposed to be a negative 7 here. So is the answer going to be negative or positive? Well, we have one negative number, okay, 2 and 3. Is 3 odd or even? 3 is odd. That means the answer is going to be negative. Okay, so now let's do some where it's going to be an even number of negatives, right? So let's do, we'll do the same example, except this will be 2 times negative 3 times negative 4. So now we have two negatives. The answer, it's going to be the same as far as the 24, right? Because it's the same numbers. But the signs, do we have an odd number of signs or do we have an even number of signs? We have an even, right? We have 1 and we have 2. And these guys are going to cancel each other out. And so it's going to end up being positive 24, right? Okay, let's say we have negative 2 times negative 5 times negative 3 times negative 7. Again, 2, 5, 3, 7, that multiplication is going to be the same. It's going to be 210 here. But now we're going to ask, do we have an odd or an even number of negative signs? And that's going to be 1, 2, 3, 4. 4 is even, so the answer is going to be positive, again, because these negatives cancel each other out. All right, so now and also this is the same for division, I should say. So if I have, 2 divided by negative 3, right, that's going to be negative. Why? Because we have an odd number of negatives, or just because, they have the different signs. You could use either of those rules. This is really the more robust rule because it works in all of the cases and not just some of them, the ones that have the two numbers. But either one works. These 2 and the 3 have different signs, so it's going to be negative 6. Or if you had, 2... Oh, sorry, that's what am I even thinking? That is not multiplication. That's going to be equal to negative 2/3, right? Because it's a division, or it's negative 0.6 bar. But we are actually going to talk about fractions in the next video, so that wasn't a very good example of mine. But okay, so now that we've done that, we can move on to simplifying expressions with integers. And this is just more practice, except I'm going to go over a couple of really important things to remember that people get stuck on a lot. So the first thing is exponents with negatives can be really confusing. What I mean by that is, let's say we have negative 2 to the 4th. Okay? And you're wondering, okay, is that going to be equal to negative 2 times negative 2 times negative 2 times, negative 2, right? I'll put a question mark there. Is that going to be equal to that? Or is it going to be equal to negative 2 times 2 times 2 times 2, right? Which one is it going to be? Because this will give different answers, right? 2 to the 4th, just by itself, is 16. This one would give us positive 16, right? Because we have an even number of negatives. There's 4 of them. So that one will give us positive 16. This one will give us negative 16 because we put the negative at just one negative at the end, right? So which is it going to be, right? And the answer is this one right here. It's going to be negative 16. And the reason why is it's related to our order of operations. And basically, you can kind of think of, if we just come back to our negative 2 to the 4th here, right? You can kind of think about that negative sign as just being like a multiplication, okay? In fact, you can think of it exactly like negative 1 times 2 to the 4th, okay? And so, what does our PEMDAS tell us? Well, it says parentheses, we don't have any of those. Then it says exponents happen right after that, right? So let's do that. So we have negative 1 times still, and then we have 2 to the 4th, which is 16. Okay, after exponents, then we have multiplication and division. So that's going to give us a negative 16. So you do need to remember to do that, right? You need to remember that the negative has to come after the exponent. That is really tricky and messes everybody up because it's really confusing. But that is how it needs to happen. Let's say you wanted it to be that other one where it was negative 2 times negative 2 times negative 2 times negative 2. Well, the way we would write that is we would put parentheses around that negative 2 and then put the exponent. Because what happens before exponents? Parentheses, right? So if we write it the same way now, so that it's going to be negative 1 times 2 in parentheses to the 4th. And now the stuff in the parentheses happens first, right? So now it becomes a negative 2, which I know I totally just wrote that anyways. And now we're taking that whole thing to the 4th. So that's going to be negative 2 times negative 2 times negative 2 times negative 2. All these negatives are going to cancel each other out because they're in pairs. And so we're going to get positive 16, right? So those are the different ways that you can write this, and they will give you different answers. And so that's why you need to be really careful about that. And that's just an important thing that comes up a lot when we have negatives. That's why I was going over it. Okay. So I'm just going to go over another example really quickly. Let's say we have 8 times negative 9, and we're dividing that by negative 2 to the 3rd. Okay, so again, we know our PEMDAS, right? What happens first? The stuff in parentheses, right? There's not really much going on here because we just have negative 9, negative 2. So we pretty much are done with that. What comes after parentheses? Exponents. So we're going to have 8 times negative 9 divided by negative 2 to the 3rd. What's that? Well, that's going to be negative 2 times negative 2 times negative 2. And we did remember, right? In this case, the negative happened first and then the exponent happened, right? Because it was this kind of a notation. As opposed to if this had not had parentheses around it, if it had been more like this, then this would end up being negative 2 times 2 times 2. So, again, we already just went over that, so I'm not going to go over it again. The 2 times 2 times 2 is going to end up being a negative 8. Why? Because we have an odd number of negatives, right? So these two might cancel, but this one doesn't. So we said 8 times negative 9 divided by, this is going to be negative 8. 2 times 2 times 2 is 8. And now, technically speaking, you might say, okay, well, we can cancel those 8s. It's not as clear here because it's not written as a fraction, so I'm just going to go through it like this. 8 times 9, or 8 times negative 9 rather, that's negative 72. And then again, we're dividing by negative 8. These have the same sign and we're dividing, so what's the answer going to be? It's going to be positive, right? And 72 divided by 8 is just 9. And it's going to be positive. Okay, so now I think, here, let me box that out. Okay. Now that we have this kind of down better, let's do some evaluating variable expressions with integers. So this is going to be really interesting. And I'm almost done, I promise. So let's take the expression. So this is just going to be variable expressions with integers. 4x squared minus 2xy plus 3y squared. And I'm just warning you, you're going to be seeing this kind of thing a lot in Algebra 2. And in this particular case, we're wanting to evaluate that when x is equal to 2 and y is equal to -1. So how do we do this? Well, it's exactly the same as how we've been evaluating variable expressions before. We just take those variables, and wherever we see them, we replace them with the value that we see right here and right here. So this is, and it's really important, put parentheses when you put these in. So don't just write 2 squared. Put parentheses around it every time. It's going to make it a lot simpler, because when we come to something like the y squared, you'll see, here, let's go, okay, 2 times -1, okay, and then plus 3. See, if we had just put in -1, right, something like this, squared, we run into this problem again that we saw up here, and we don't want to do that. We have to make sure we put these parentheses around it. It makes it a lot simpler. So, and correct. And so now we can just evaluate this like we normally do. So again, parentheses, there's not a whole lot to do. It's just negative numbers that we put in parentheses just for the sake of it. So we don't have to do much with that. Exponents comes next. So this is going to be 4 times 2 squared is 4. Then we're going to have minus 2 times -1 plus 3 times, okay, -1 squared, that's -1 times -1, right? Which is, those negatives are going to cancel. We're going to get a positive 1. 1 times 1, or -1 times -1, positive 1. Okay, now we're going to do all our multiplication, right? So 16 is 4 times 4 minus, and I'm going to put this in parentheses. 2 times 2 is 4. 4 times -1 is -4. Okay, then we're going to add, and 3 times 1 is just 3. Okay, and we've already talked about how two subtractions, or a subtraction of a negative is really just an adding of a positive. So this is the same as 16, these cancel, plus 4 plus 3, which 16 plus 4 is 20, and 20 plus 3 is 23. So that would be our answer there. The last thing I'm going to do is just a quick word problem with integers. So this says, in the morning, well, okay, yeah, I'm not going to write out that whole thing. I'm just going to write out the relevant information. So, in the morning, the temperature in Kendallville, Indiana, was 11 degrees, right? So 11 degrees. It doesn't tell us Fahrenheit or Celsius. It doesn't matter. By mid-afternoon, temperature dropped to -9 degrees. See the negative number there that they snuck in? What was the difference in the morning and afternoon temperatures? So if we think back to what we learned last time about, putting expressions into words and things like that, you might remember the difference is the same as subtraction, right? So all we're going to say is 11 degrees minus -9 degrees, right? We got to put that in parentheses, so that we can't just say 11 minus 9, right? Because we have that -9. So 11 degrees minus -9 degrees is going to equal, those negatives cancel and make a positive, right? So this is 11 degrees plus 9 degrees, which is going to give us a 20 degrees difference, right? So that would be our answer. All right, so that's the end of the integers section in Chapter 1. That was 1.2 of the OpenStax textbook that I'm following along with. So again, there are more exercises in that textbook if you want to keep practicing this. Otherwise, if you have any questions, you can contact me. I'll put all my my email and stuff in the description of the video, or you can go to my tutoring website, and from there you can there's like a Q&A section where you can send me an email, or there's you could actually schedule a one-on-one tutoring session with me, and we can work through those questions. So I hope that this was helpful to you. Next video is going to be talking about fractions, so it's going to be pretty much the same thing. We're talking about adding, subtracting, multiplying, dividing, except we're going to do that with fractions instead of integers, so that's going to be interesting. Again, just work through more problems. You'll get this down really quickly, I'm sure, and I'll see you in the next video.